Suppose a comet of mass mc is orbiting a star of mass ms in an elliptical orbit as shown. The distances of the comet to the center of the sun are given. At what point does the comet have the greatest speed, and why? Well, if we think about just the comet's motion, okay, we got a little comet here, it's flying around, okay, and we think about the only force that's acting on it is gravity. But if you think of the comet plus sun system, because if you think of the only force here acting on the comet at any point in time is just from the gravity from the sun. Okay, but if we include the sun as part of the system, this force doesn't do any work. This is the only external force acting on the comet, and it doesn't do any work because we've included the sun. It's an internal force now. It's part of the comet-sun system. So the total energy has to be conserved, right? So what kind of energy are we talking about here? Well, you're far away, so you have gravitational potential energy and you have kinetic energy. Those are the two forms of energy we would talk about in such a system, right? That it has some speed. So first about the gravitational potential energy. So if the total is constant and you wanted to go to the fastest, then the kinetic energy plus the gravitational potential energy, let's write that out as constant. Now, what's the kinetic energy equation? It's 1/2 mv squared. What's the gravitational potential energy equation? Well, when you're far away from the surface, it's not mgh, it's negative g. Mass of the star, mass of the sun, divided by r, the distance. Okay? Now, so that means the kinetic energy, you can solve for this, is equal to whatever the constant is, plus g mc ms over r. Okay? Now, how do you get this quantity to be as big as possible? Is if you want this quantity to be as big as possible, right? And this is big when r is small. Okay, so that's true about gravitational potential energy. When the comet is closer to the sun, it has less gravitational potential energy. And that makes sense because near the surface, we say when we're closer to the surface, we have less potential energy than if we're higher than the surface. So the comet, by virtue of having less gravitational potential energy, has the most kinetic energy at this point and the least kinetic energy at this point. And it has the most gravitational potential energy here and the least gravitational potential energy here. So that's the explanation. So where does it have the greatest speed? A. Where does it have the slowest speed? C. So that's the explanation. You could write it out in words, but that's the explanation we're gonna say. We're gonna pretty much say that the total energy must be the same because energy is conserved in the comet-sun system. And then at A, it has the least gravitational potential, thus has the most kinetic energy. And if you have more kinetic energy, then you're moving faster. You have a larger speed. If the speed at point, so part C, if the speed at point C is VC, so we're moving with VC here, what is the speed at point A? So let's do the whole gravity. So we'll do the energy here equals the energy here. So what's the energy here? It's 1/2 m, the kinetic energy there, plus the gravitational potential energy with the sun. And then at point C, we would say it's 1/2 mvc squared, the kinetic energy at that point, and then minus. This is a key part, gravitational potential energy when you talk about from far distances. Not squared. It's a negative quantity. Okay. What's the speed at point A? So we want to solve for V. So we're just going to add that to that side. So we have 1/2 m VA. Oh, sorry. This m is the mass of the comet, right? VA squared is equal to 1/2 mc VC squared minus g ms mc over RC, then plus g ms mc over RA. Now you see there's an MC in all the terms that we're adding up, so we can just divide them out and cancel them. I'm going to multiply by 2, and then I'm going to take the square root. So 2 times this would make this VC squared. And then I'm going to factor out the GMS. So we'll say it's plus GMS times 2, because we have this times 2 we got to factor in, and we're going to factor out 1 over RA and then minus 1 over RC, or negative 1 over RC plus 1 over A. And so VA would be the square root of that. Okay, just like that.